Applications of linear equations. Okay, so now we're going to use all the techniques of solving in tasks 1 through 5 to solve word problems. So let's look at some examples. Okay, example 1. Reed earns $60 per day and $3 as commission for every watch that he sells. His daily earnings goal is $150. Write and solve an equation to determine how many watches, X, Reed must sell in a day to meet his daily earnings goal. Alright, well, what does the variable represent? Kind of tells us in the problem, right? It says watches, comma, X. So X represents the number of watches that Reed sells. So we'll just say watches. And it's the number of them, right? Okay, so step 2. Determine what is constant, aka is not changing daily, and what is changing based on the variable. Okay, so what stays stagnant and what does not move? Well, it says Reed earns $60 per day and $3 as commission for every watch that he sells. Which one of those is guaranteed on a daily basis? Well, $60, right? Because he earns $60 per day no matter what. So that's going to be the constant. And what is changing depending on his commission and the watches? Well, that's $3, right? So he gets $3 per watch. So that's what's changing. Okay, so step 3. This equation will usually be set up in this way. Set up the equation using this. So our changing number, that's right here, 3. And then we want to put an X right next to it. That's what that parentheses X means. Plus the constant, which is 60, equals the end product. Now, we haven't talked about the end product yet, but does it talk somewhere about how much money Reed wants in the end? Yes, it does. It's right here in the red underline, right? His daily earnings goal is $150. So that is what our end product is. That's what goes right here, $150. Now, the good news is from here we just solve using techniques from tasks 1 through 4. So we're going to draw our line down the equal sign. We want to get the X by itself, right? So first I want to subtract 60 from both sides. Cancels over here, and I'm just left with 3X on the left-hand side. 150 minus 60 gives me 90. And now, how do we undo multiplication that's happening here on the left-hand side? We want to divide, right? So we divide both sides by 3. These 3's cancel. We're left with X equals 30. So remember, back to the original problem, it was talking about number of watches, right? So he must sell 30 watches to make his goal. Okay, let's try an example. So it says, a 15-foot tree casts a shadow of 5 feet. Assuming that the height of a tree is proportional to its shadow, how long of a shadow would a 35-foot tree cast? Alright, so what does the variable represent? Well, we're not quite sure. Like, it doesn't tell us as obviously as the last problem. So let's go to the question that the problem is asking, and that will help us. It says, how long of a shadow would a 35-foot tree cast? So we could say that X would represent, well, the length of the shadow, right? We want to know the length of the shadow of the 35-foot tree. Oopsie. Okay, step 2, it says, find the two quantities in the problem. Now, quantities kind of represents the two topics that it's talking about in the problem. So we can see the problem has this trend. It's saying the height of a tree, right? And then what else is it talking about? It's talking about the tree's shadow. So we can say quantity 1 represents height of tree. We can say quantity 2 represents the shadow of the tree. Alright, so now we're going to set up a proportion since it said that the height is proportional to its shadow. So quantity 1 was the height of the tree. Now, we know that the 15-foot tree, we're going to put that up here, over quantity 2, I'm getting that from right here. Well, quantity 2 is a shadow, and it tells us that the shadow is 5 feet. So 5 goes here. Okay? Now, we want to move back up. Quantity 1 is the height of the tree. So we know that the height of the other tree is 35 feet, so that goes here. And we don't know the shadow, right? But we want to know the length of the shadow. That's our x. And now that we have set up our equation, we can solve. So step 3 says solve for x by using cross multiplication. So we're going to cross multiply, and we get 15x equals 175. Now how do we get the x by itself? We want to divide by 15, right? Divide both sides. They cancel over here, and I'm left with x equals 11.67 feet. So that would be the shadow that the 35-foot tree would cast. Okay, one more example. It says, Sam and Brett each opened a savings account on the same day and agreed to both withdraw money weekly to spend on what they choose. Sam opened his account with $810 and withdrew $100 per week. Brett opened his account with $410 and withdrew $20 per week. In how many weeks, X, will they have the same amount of money in their savings account? Okay, so what does the variable represent? Well, we can see here it's going to represent the number of weeks. So we're going to say X equals weeks. It's the number of weeks. Okay, determine what is constant, which is what we did on example 1, and what is changing based on the variable. All right, so let's start with Sam. So I'm going to underline where it talks about Sam. Sam opened his account with $810 and withdrew $100 per week. Which one of those is constant, and which one is changing based on weeks? So, well, what stays constant? He put in $810, and that doesn't change. Okay? What is changing is the amount taken out each week. So he's withdrawing $100 per week. So that's what the changing amount is. In the same way, let's look at those numbers for Brett. So it says Brett opened his account with $410 and withdrew $20 per week. So for Brett, $410 is his constant, and his changing is $20 per week. Okay, so step 3 says the equation will usually be set up in this way. Set up the equation using this. The blanks will either be pluses or minuses, depending on the problem. So in this problem, we want to think about what they're doing with the money. Are they putting money in the accounts? Are they taking money out? And if you look at the wording, it says they're withdrawing money weekly to spend. So they're taking it out. Therefore, in this problem, these are going to be minus signs. If you're adding things, then you'd use a plus. Okay, so now we're going to plug in our constant for Sam on the left-hand side. So 810 minus 100 x equals, now we're going to do the constant for Brett. 410 minus 20x. And we're almost done. Now we just solve based on what we learned in this part. So we're going to draw our line down the equal sign. I'm going to start by adding 20x to both sides. Okay, and I get 810 minus 80x equals 410. And now I'm going to move this 810 over to the right side by subtracting it. Those cancel, and on the left-hand side I'm left with negative 80x equals negative 400. Our final step, we want to divide both sides by 80, negative 80. And we get x equals 5. So in 5 weeks, Brett and Sam will have the same amount of money in their savings account.